October 17, 2025, scientists watched in disbelief as Kilauea's summit split open, launching a lava fountain 1,200 feet into the dawn sky. It was the highest eruption here in over half a century, and no one saw just how fast it was coming. So, what did the island's most advanced sensors catch before disaster struck, and why were the warning signs so easy to miss? Around the clock, a network of sensors and scientists stands guard at Kilauea's summit. Deep underground, seismic stations track every tremor, while tilt meters perched on the caldera rim register the faintest swelling or sinking of the Earth. In the control room, banks of monitors flicker with real-time data, earthquake patterns, ground deformation, gas emissions. Each stream watched by duty geologists who know that minutes can make all the difference. The mission is simple, but relentless. Detect the first signs of trouble, confirm the threat, and alert the island before danger breaks the surface. This vigilance is not just protocol, it's a promise. As one monitoring team leader put it, our job is to see what the volcano is saying, even when it's quiet. The surveillance never stops. Every spike in tremor, every subtle shift in tilt is analyzed against alert thresholds set through years of experience and hard-won lessons. The instruments feed a continuous flow of information to the team, who cross-check readings, debate anomalies, and prepare to escalate warnings if the volcano's signals intensify. The result is a layered defense: satellites overhead, gas sensors in the air, and boots on the ground, all focused on one goal: catching the moment when Kilauea stirs. This is the silent choreography behind every public alert and every calm night on the island. The watchers on the rim know the stakes. For them, vigilance is more than a job, it's a creed. Over a 2-week span, the summit's silence was broken by a steady drumbeat of earthquakes. Instruments mapped a swarm beneath Halemau'uma, each tremor plotting a path as magma pressed upward. In the last 36 hours, tilt meters on the caldera rim tracked a sharp rise in ground inflation, an unmistakable sign that the volcano's upper chambers were swelling under pressure. The ground lifted by several centimeters, and the tilt curve steepened into a near-vertical climb. Infrared satellites picked up a sudden heat bloom at the summit the night before the eruption. On the ground, airborne sensors flying over the crater recorded a surge in sulfur dioxide emissions, jumping from typical levels to more than 14,000 tons per day in the final hours. The air grew thick with volcanic gases, and the summit's thermal signature intensified, lighting up satellite frames with a bright pulse. Each data stream, swarm maps, tilt graphs, satellite images, told the same story. Magma was on the move, the summit was primed, and the system was crossing a threshold. Scientists compared the patterns to past eruptions, debating how much time remained before the surface would give way. By the evening of October 17th, every metric pointed to imminent change. The volcano was no longer whispering. It was shouting through every instrument, warning of what was about to unfold. At 8:05 p.m. on October 17th, the summit of Kilauea erupted with sudden force. The first vent tore open on the north side of Halemau'uma crater, sending a jet of molten rock hundreds of feet into the darkness. Within minutes, the fountain's roar competed with the deep rumble beneath the caldera. Orange light flashed across the rim as the stream of lava climbed higher, casting shadows that danced along the crater walls. Scientists at the observatory radioed in confirmation, their voices tense as the initial burst sustained itself at full strength. 45 minutes later, a second vent opened to the south. The two fountains surged in tandem, each feeding a growing pool of lava that began to swallow the crater floor. The south vent quickly outpaced its northern neighbor, its column of fire rising with relentless energy. By 9:30 p.m., both vents were in full eruption, the air thick with heat and the ground trembling from the force of the jets. Through the night, the spectacle held. The fountains pulsed and shifted, sometimes merging into a single wall of fire, sometimes splitting apart as pressure fluctuated beneath the surface. For more than 7 hours, the eruption continued, lava arcing skyward, incandescent fragments raining down, and the sound of the volcano echoing for miles. The sequence played out in real time, unbroken, as the vents maintained their fury until the early hours of October 18th, when the fountains finally began to wane. Verifying the true height of a lava fountain is a test of both technology and trust. When reports of a 1,200-foot fountain first spread, geologists at the Hawaiian Volcano Observatory turned to a methodical process: photogrammetry. Using synchronized footage from multiple cameras stationed around the caldera, each with precise GPS coordinates and lens metadata, they set out to separate spectacle from measurable fact. The process begins by anchoring the camera's field of view to known reference points. In this case, the caldera rim and specific ridgelines visible in the background serve as fixed baselines. Each frame is mapped pixel by pixel against these landmarks. Scientists then calculate the apparent height of the fountain as it rises above the rim, adjusting for the exact distance from camera to vent, just over 1,200 meters in the main Geology Hub video. Every calculation accounts for the focal length of the lens, the angle of observation, and the curvature of the terrain. To ensure accuracy, at least 2 independent vantage points are used. The north and south vents, both captured in the same frame, allow for cross-verification. At the eruption's peak, the south vent's fountain soared to nearly 1,500 feet, about 460 meters, while the north vent reached around 1,100 feet. These figures are not estimates, but the product of 3-step triangulation, checked against USGS topographic data and webcam overlays. While the margin of error is small, typically within 5%, scientists are careful to clarify that atmospheric distortion and camera placement can introduce minor uncertainty. Still, the numbers hold. The 2025 Kilauea Summit eruption produced the tallest lava fountain seen here in more than half a century, its height confirmed not by rumor or viral clips, but by rigorous, transparent measurement. Lava bombs the size of cars arced over Halemau'uma's Halemau'uma rim, slamming into the crater's edge and sending shockwaves across the summit. The floor of the crater vanished beneath new lava, its surface buried in a matter of hours. Civil defense teams enforced a strict exclusion zone around the rim, warning that even a brief approach could be fatal. Volcanic gases rose in a dense plume, pushing sulfur dioxide levels to 14,000 tons per day and triggering air quality alerts for downwind communities. Schools in Ku and South Kona closed as fog drifted through, and clinics reported a surge in breathing problems. For those near the summit, the risk was immediate. Ballistic projectiles, searing heat, and toxic air combined into a landscape where survival depended on distance and vigilance. At first light, the summit rim drew quiet figures, some alone, some in small groups, gathered to honor Pele's presence. Traditional chants carried on the wind blended with the distant rumble from Halemau'uma. Ceremonial offerings of lei and flowers lay beside the path, each a gesture of respect to the goddess whose home is the crater below. For many native Hawaiians, this eruption was not just a spectacle, but a living sign. One practitioner explained, "She is here. Respect must be paid and warnings heeded." Residents in Volcano Village described the night as brighter than sunrise, a glow that filled their windows and hearts with awe. In these moments, humility and reverence shaped the community's response, reminding all that this land is alive, and its power demands both caution and gratitude. Within hours, #1200-foot lava fountains surged across social media, trending on major platforms as thousands shared eruption clips and bold claims. TikTok and Instagram feeds filled with dramatic footage, some accurate, others wildly exaggerated. The viral wave drew crowds to the summit, with a handful crossing into closed zones in pursuit of the perfect shot. Rangers issued warnings and citations as drones buzzed overhead, ignoring park regulations. Officials pushed out real-time updates, trying to counter rumors and reinforce boundaries, but the rush for views often outpaced verified information. The spectacle became a digital contest, with safety sometimes left behind. At dawn on October 18, 2025, Kilauea's summit sent a lava fountain soaring nearly 1,200 feet into the sky, the tallest seen on the island in over half a century, as verified by photogrammetry and official USGS records. Data from 24/7 seismic and gas monitoring revealed a 2-week swarm, a 36-hour inflation pulse, and a final surge in sulfur dioxide just before the eruption. Yet, despite this detailed surveillance, the precise triggers behind Kilauea's sudden ruptures remain under study, as do the long-term impacts on the crater's structure and local air quality. For residents and practitioners, the event became both a risk and a moment of cultural reflection, drawing global attention and sparking a wave of viral coverage. As documented evidence shows, Kilauea's fountaining is both a scientific puzzle and a living force, one that demands respect, vigilance, and ongoing research.